My name is Junaid Islam. I work at a small company called Vidder. We do cybersecurity work, primarily for banks and government agencies. I started my career at Cisco, where I worked on MPLS and VoIP on the protocol side, and then have spent time doing different work. So what I'd like to do is give you kind of a different perspective. Joe talked a lot about the issues with deploying V6, and he talked about some of the benefits, and I want to finish this day by just expanding on those benefits so you get a sense of how people think about V6 and where it's going. One of the important things I really want to talk about is there's a lot of people have talked about IPsec in V6, and it's kind of confusing what that means. And I just want to give you the answer from a high-level perspective because I think it's really important. When the V4 protocol was developed in the 70s, there was no concept of IPsec or VPNs. That really started happening in the 80s, and then in the 90s, people like Cisco created products and NetScreen and others, and there was a whole industry. But because of the difference between when the V4 protocol was developed and productized in forms of routers and when VPN came out, VPNs had to be added as a separate box. However, by the time we started working on V6, we kind of knew that we wanted security, so we included the headers, which is really the piece that allows you to VPN something into V6. This means basically V6, unlike V4, can inherently be a VPN. Now, the reason this is important is VPN boxes cost a lot of money. And if you can basically have integrated security into your routing protocol, this dramatically drops the cost of security. And I find it's kind of ironic where people talk about what's the business case for V6, where the business case is completely relative to the amount of money you spend on security. So you can bring down the cost of security by many orders of magnitude. And I think a great example of that is the DoD, where some of us have worked, and I know Joe has worked. Their driver was not address exhaustion. They have an infinite pool of private non-routable addresses. Their interest was in securing a lot of mobile devices as they move around the world. So that was the driver, and they were one of the people who pushed for the IPsec implementation. So I think that's really important to remember when we talk about V6. So what I'd like to do in the next few minutes, to keep it short, as I see people are setting up in the back there, is give you a perspective of why I believe the IPsec piece of V6 is actually the most valuable piece. I actually don't think it's the addressing. So that's where I differ a little bit. So today, the biggest topic in the news is cybersecurity. That's all we talk about. I mean, President Obama talks about it, there's issues in Washington, and everybody's looking for network-based cyber mitigation attack schemes. Meanwhile, here comes V6, and V6 has integrated IPsec and address hiding, and has the ability to swap algorithms. It supports AES right out of the box. And I really think it's two ships passing in the night. It's just incredible that, here's a new protocol with all these features, and nobody talks about how it mitigates all these cyber attacks. But hopefully, by the time we get through my talk, you'll have a sense of it. So let me talk about the V6 cybersecurity value from a high-level perspective, and I'm going to talk about it a little bit from a business perspective instead of just at the protocol level. Today, the biggest drive among enterprises and government agencies is to save money, whether it's through looking at virtualization architectures, cloud architectures, outsourcing, SaaS. This is a theme that's happening around the world, as actually probably all of you know from your day jobs. I bet this is a big part of your job. But the biggest challenge by far in all of these new cloud architectures is security. VPNs, which work well, having worked at Cisco, it's a great solution, are very expensive to deploy. It's almost hard to say, we're going to save, so many hundreds of thousands of dollars by consolidating servers, but wait, we have to buy all these VPN boxes and then provision them. That's a non-starter. So the alternate to that is a software-based solution. And of course, the best software-based solution is SSL. But SSL has a lot of problems. For those of you who know, the first hello packet in SSL uses DNS, which can be easy to hijack, and once you can hijack that, you can do a man-in-the-middle attack. What's worse is, with new graphics chips, a lot of people are now starting to try and read the SSL packet directly on a PC. 2 or 3 years ago, that was considered impossible. But now, because we know what the key size is and we know what the message type is, you can buy one of these NVIDIA things and let it sit there, and half an hour later, it'll actually read the packet. So we need a new solution, and I think the correct solution is IPv6 as an overlay architecture done in pure software. So like SSL, you can deploy it in software, but it's IPsec, and you can run AES. And isn't that cool? Oops, wrong way. So what does that look like at the 100,000-foot level? Think of IPv6. You guys are all experts in 6/4, so there's any number of ways to do this. But now what we do to the 6/4 endpoint, we add an agent. And the purpose of that agent is basically to configure the IPsec header, which is there in all the v6 stacks. So this is not something you actually have to buy. You just have to configure the authentication header and encryption header properly. But once you can do that, you can basically set up a software VPN. This is a 6/4 VPN that routes from destination A to destination B, and basically the VPN lives as an overlay. The interesting thing is this VPN operates just like a v4 VPN, but the benefit of v6 has two parts. One, because the v6 address space is orthogonal to the v4 space, it's collision free. If we try to do this with v4, like at 2 arbitrary points, we have to really check the addressing to make sure that it doesn't conflict with something, otherwise it blows up. The other thing is v6 is now supported in application servers and browsers, so that if I had this slide 2 or 3 years ago, it'd be really hard to do, but right now it's everywhere, so there's no problem in doing this. So from an enterprise perspective, what does this mean? Think of an enterprise that has 3 departments, and they have a whole bunch of servers, and there's a lot of replication. Now, with this kind of v6 architecture and overlay, they can create not just one overlay network, but different departments can create multiple overlays for themselves that they manage by application. So a department can create, think of 3 VPNs, one accessing their accounting server, one accessing Oracle, one accessing some kind of Java server, all running in parallel. So that's the beauty, because once you know how to create an overlay in software, why stop at 1? You could do 10, you can do 100. And if you look at a lot of the work that's being done now by the intelligence agencies in Washington, a lot of them are actually now heading this way, where they're talking of spawning millions of VPNs, where only a few of the million might be in use, but from a security perspective, you would never know. You just see, terabytes of encrypted traffic. So let me now go to the kind of 50,000-foot level and show you how this looks like a little bit more clearly. So one of the powerful concepts with overlay networks is we can effectively create a private cloud in a public cloud. And this is an example of the kind of work we do for some of our agency customers. So what we do is obviously, putting an app in a VM is pretty standard. But you can take your 6/4 VPN endpoint and as a VM, install it in Amazon, and it actually generates tunnels going out. So Amazon doesn't need any v6, right? You're just, as far as Amazon is concerned, you're just a v4 app, and you can terminate these tunnels. So sitting on the outside world, people have a 6/4 client, and they can basically tunnel into this gateway, which then unpacks your v6, which is unpacks the v4 tunnel, terminates the v6, decrypts it, and VMware has a really nice feature. It's called a virtual switch. So what you do is you can, once you terminate your v6 traffic and decrypt it, you can basically use the virtual switch feature to go from one VM, which has your v6 VPN, to the other VMs which have your application server. So this is kind of interesting. The topology of what lives in the cloud is now the same as what lives in a real data center. If you think about a real data center, you've got a VPN box, a switch, and servers. Now you can actually recreate this whole thing in the cloud, and the combination of the v6 overlay addressing, which is independent from what Amazon gives you or GoGrid, and the integrated IPsec lets you do all of this in software. So this is a very powerful concept, which I think is really going to drive enterprise adoption of v6 over the next few years. I really don't think it's going to be some of the other things. I think it's this kind of cryptographic benefit. So from a security perspective, let's look at this kind of architecture and let's compare it to some popular cyber attacks and see where it holds up. So from a DNS proxy perspective, so DNS attacks are common. They happen from China and other places all the time. Basically, the DNS services live inside the v6 overlay. So from a user perspective, they're still using DNS, but they're using the DNS of the organization, so you can control that. Let's talk about a user replay attack. This is a common cyber attack where, as you know, people will listen in, see what you've signed into, and then just try and do that again. The beauty of an overlay architecture is every time you spawn it, you can use different combinations of v4 or v6 addresses. So for someone who just wants to replay what they just see you doing right here, it's very hard to do. The address space of v6 is arbitrarily large, so you can do a random walk for all of the v6 elements over the v4, and it becomes very hard to break. From a DDoS server attack perspective, the actual application servers are hidden. If we just look at this picture quickly, imagine this is in Amazon. Right now what happens in Amazon and other cloud services is the app server you buy is sitting right out on the internet. So anybody with a packet sniffer can watch the packets leave your organization and figure out where you're parked in that cloud and then do a DDoS attack or try and break into it. In this case, there's actually a VPN box, virtual VPN box, in front of your app server, which basically is only accepting 6/4 traffic from authenticated users. And the application servers themselves won't accept traffic from anywhere else. So this creates a very simple solution. That's a very effective DDoS mitigation scheme. From a DPI surveillance perspective, we can run AES encryption. The other important thing here is because the encryption is done in software, you can also swap encryption modules. So for people who work for government agencies, that's really important, being able to take out one module. The other place this is important is there's a whole class of devices, whether it's phones or smart meters, that can't run complex block ciphers like AES. So they have the opposite problem. They don't have the CPU. So there's Google is working on new sets of applications called TEA, or Tiny Encryption Algorithm. These are block ciphers which are very efficient. So the nice thing is within this overlay architectures, we can not only run complex block ciphers, we can run low complexity block ciphers to enable end-to-end security. And then finally, brute force crypto. With everything being encrypted all the time, with the keys being changed in every session, this type of attack is now effectively impossible. In fact, it becomes so difficult, it becomes much easier just to, pay an employee for information than to try and break the network. And from a network administrator point of view, that's where you want to reach. You don't want to be the person who gets in trouble. You want to say, look, I've secured the app. If there's a leakage, they've paid somebody, so, it's not my problem anymore. So where this leads up to is the beauty here is with v6, we can create really an infinite number of VPNs for applications, for devices. This, ironically, was actually a part of the initial vision when IPsec was introduced into the v6 protocol. And somehow it got lost over the past few years as people talked about addressing and other things and depletion, which are important, but I think this is a really powerful benefit of v6, and I believe it'll be critical to the adoption within the enterprise and the government here. So with that, I'm doing one of these things that you should never do in a conference, which is trying to do, let's see if this works here. Actually, I tried to see if this would work before on the Wi-Fi, but the port that I was using for my IPsec VPN wasn't working, but we'll see if this works or not. But I kind of wanted to show you this working, but even if it doesn't, one of the nice things about this feature, this is actually a IPsec VPN client that first sets up, it's not going to work, first sets up a 6/4 time, oh, actually it does work, my God. So what this demo shows you, I'm going to show you two things. I'm going to show you setting up 6/4, which is kind of the baby step. I think most people here know how to do that. And two, I'll show you turning on IPsec inside that 6/4 connection, and I'm doing it all in software. So the point is, we can create IPsec anywhere without any hardware. So this is an example of a IPsec 6/4 client supporting AES, and it's controlled by a web app. So I've just signed in as myself, and what I've done is I've just set up a tunnel, and I haven't done any IPsec here. So let's see if this tunnel works. No? All right. So what this, we'll see if that works or not. But what this allows me to do is through a web app, oops. Oh my God, no, not today. What this allows me to do is through a web app is move clients into different VPN groups. And the interesting thing here is we can set up an arbitrary number of VPNs and software, where if this was done in hardware, we'd actually have to buy boxes and deploy VPNs. And as we create these VPNs, we can move users around in those VPNs simply through this drag and drop interface. So as with all live demos, if you try and do them, especially sitting in front of a group of people, there's always something bound to go wrong. But the important point here is, let's kill this, is that IPsec can be run anywhere without hardware. And I think this is something for those of you who work in this area and security is important to you, that you really explore and understand this, because I think this is the kind of most powerful part of V6 which gets least talked about. So with that, I think there's going to be a break soon, so I think we have a minute for a few questions. Yes, sir. Thank you.
So how would you compare this solution to what Microsoft has with direct access?
Yeah, actually, so what I'm showing you is the open version of direct access. So just so you know, for those who haven't heard, Microsoft is offering a free VPN in direct access, and it's actually a great solution, and I'd encourage everybody to do it. Now, the catch in the Microsoft solution, there's always a minor catch, is the VPN has to be all pure Microsoft. So you need Windows 7, you need Server 2008 to run the app, but if you can do all of that, that's fine. So the reason what I'm showing here is the non-Microsoft version can basically work with anything. So Microsoft is actually putting a lot of effort into direct access. I think some of it is being driven by their government customers who want a strong cryptographic solution within the government agencies. I think it's also being driven by enterprises who want to save money on VPNs. And I think I'd encourage you to look at the Microsoft Direct Access website. It's actually very well written, and they make it pretty clear that you don't need to buy a VPN box anymore. You know, and their catch is you have to buy all Microsoft, which, but you know, they got to make their money somewhere. Great. No other questions? So great. I thank you for your time, and look forward to talking to you later. Bye.